Hi, hello. This is Chandrasekhar Pri from ATMI College of Engineering, working as an assistant professor in Department of ECE. So today I am going to give an explanation on an distance vector algorithm on a computer networks lab. Distance vector routing. The first thing, each node creates its own least cost tree with the information, and it has about its intermediate nodes. Once the incomplete trees are exchanged between the intermediated neighbors to make the tree more and more complete and to represents the whole internet. Distance vector routing protocol uses the Bellman-Ford algorithm and also uses Ford-Fulkerson algorithm to calculate the best route in a network. The term distance vector refers to the fact that the protocol manipulates the vectors of a distance to other nodes in the network. The main purpose or the origin of the distance vector algorithm is to find the routing algorithm for an ARPA net and was implemented widely in an LAN, that is a local area network, with the routing information protocol RIP. The main distance vector algorithm is used to find the address resolution protocol and reverse address resolution protocol. The algorithm of the distance vector is carried out by following. First, we need to read the number of nodes and the path of a network. Read the distance matrix from each user and represents those distance, what we call as a cost distance of each node which is connected to the neighboring nodes. So once we got an information of a neighboring nodes cost and a distance of each node, we need to store the values in a suitable variable and we need to display the complete routing table. Once we get the complete routing table, then we enter the source node and the destination node to find the shortest distance between the source and the destination. By calculating the minimum distance between two nodes is done by method called retracement method, and if the distance cost between the two nodes is smaller than the available path, replace the existence distance with the calculated distance. Finally, we get a shortest path that has to be displayed and has to be calculated, and its cost between the source and the destination source node and the destination node has to be taken into consideration. So this will be calculated for each and every path what we have been entered, and finally by the calculation we will able to get the shortest path. So let us look over to the program. So as I said, that first thing we need to read the values. So to read the values we need to consideration the matrix. So to read the matrix we need a two variables which are called as a integers I and j, where is I used for a row and j is used for a columns. So here the values what we are going to take, the cost of a matrix will be stored in ai of j, a I of j. Next, the path what we are going to enter is stored in n p, and the possible path which is going to represent in the form of a matrix are stored in path of I and path of j. So these are the variables. Apart from these variables, a minimum is an integer which is used to find the minimum distance, which is considered as a variable, and st is the starting time or a starting point, and ed means ending destination, and as an intermediated signals or an variables we are going to use an a index, which is an type of an integer we are going to consider in the program. First thing, we need to enter the cost matrix. So to enter the cost matrix we are going to use an a for loop. So in an for loop, for an I is equal to 1, I is less than or equal to 5 and I of plus plus. So this will be used to take the values in a row wise, and j is used to take the values in an column wise. So here matrix what we are going to take is a 5 cross 5 matrix. This is depends upon the a designer or an user or a network designer to how many nodes is need to be considered, and those values what we are going to enter the cost of a matrix, that is a distance of a matrix from a one node to another node and a neighboring nodes, is stored in an a of I and j. Similarly, we need to enter how many number of paths are available from the source to the destination in a network designed in a design network, and we need to enter the possibilities of the path from the source to the destination. Once we that is total number of a path from the source to the destination. So in the source to the destination number of path, we need to specify which are those paths. For an example, if I say there are in 4 paths in my design to reach the destination, means I need to specify which are those 4 paths. So to specify those 4 paths, we use an one more integer variable which is called as an path of ij, which gives the enter the possible paths. So once the path has been entered, next will come to a first case, that is the counting starts, which is the first variable I of that is I of 0 0, that is the first element. So when I going to take a first element, that is going to consider, and it check for the end path, which is the end path which is given by then that is path of I, that is path of 0 0 plus 2. Next similarly the j will be gets incremented, and finally we find the a path which is be calculated by equation t of I is equal to t of ti plus st of p and ed of p. So if the ed and stp, that is then the ending destination and the ending destination path are both are equal, the programs gets break and directly it will finds the minimum distance in an path. If not, it will be take considering that if the same, so the starting point and the ending point are one and the same, means then it has to calculate what is the minimum distance. So in most of the program, usually this program, this ending point and the starting point doesn't be provided. Next we'll calculate what is the minimum distance. So to calculate the minimum distance, I have a condition called if minimum is greater than t of I. For an example, if t of I is a value of 3 and the minimum will be greater than, so minimum what I have been considered, minimum is nothing but t of s comma t. So s of t is nothing but the source time or a source path index. So is this value is greater than, then it will consider which is the minimum, and those value has to be get printed as in minimum cost matrix. If not, then it will going to check for the another path and it will assign directly the path of index is equal to 0 and break the path. So this is the simplest way to calculate a distance vector from a source to the destination, that is the shortest path from a source to the destination. So let me see the what will be the output of this. So as I said that first I need to enter the cost matrix. Here the cost matrix is 0 1 4 2 0. That means this 0 means from node 1 node 0 to node 0, node 0 to node 1, node 0 to node 2, node 0 to node 3, node 0 to node 4. Similarly node 0 to nodes node 1 to node 0, that is x-axis and an y-axis, that is I and an j. So these are the I axis, these are the j axis. Like this we have taken an 5 cos 5 matrix. That is similarly from an 0 to we don't have any cost, so at the last path we don't. So when I find in my network, I found an a 4 paths, so I am going to enter the number of paths that is available in my network is 4. So I need to write in which are the possible paths, that is which are those 4 possible paths. So that means from a node 1 to 2, 2 to 4, 4 to 5, 5 to 0. That means when I calculate the first path, the total cost of this is how much? 5 plus 4 plus 9, 9 plus 2, 11, 11 plus 1, it's 12. Similarly it will going to calculate what is the the value the total distance in a path called 12500. That means 5 plus 2 7, 7 plus 2 8. Next similarly 9 plus 1 10, and last finally 1 plus 3 plus 4 plus 5 9 10 13. So when I compare to all these values, when I compare to all these values, let me write the values of this. 5 plus 4 is 9, 9 plus 2 is 11, 9 10 12. So total here is 12. Similarly 5 6 7 8, the total cost is 8 for an second path. Similarly for an third path, the total cost is 10. Similarly for an final, the total cost is 5 plus 4 is 9, 9 10 13. So when I consider this path, I need to find which is the shortest path. So minimum cost is what is in 4. So hence the path will be from an 1 to 2, 2 to 5. That is from an 1 to 2 and 2 to 5. So this is the minimum cost path matrix. So we are going to be taken into a consideration. So thank you. Hi everyone. Welcome back to the program distance vector algorithm. So in a last session I have explained about and how the distance vector algorithm is is the logic of that. So now I am going to show the demo of it. So to do that, right click on the desktop, select a new document and select empty document. So your file is going to be created, and save the file with an extension called .c, because we are writing a program in a .c. Already I have gotten a program, just I am going to paste it. So once again I am going to recall this program. So this path is used to enter the possible paths of a network, and this I and j are the integers which is taken into consideration to write the matrix. So when I consider a matrix, I mean a matrix, I have got a rows and columns, where I is used for in rows reading and j is used for in a column reading, and I need to calculate the minimum distance which is of an integer. So, and a is used to take the number of possible cost matrix, and p is the variable which is used to take the number of how many number of paths are available in a network, and st and ed, stp, edp are an intermediated signals which are considered as an integers for the starting time of the source time and the destination point of the network. So apart from this, and first we are going to enter the cost matrix for a given network. Once we write down the cost matrix, for this we are going to find out how many number of possible paths are available from the source to the destination. So when we get a possible number of paths, we need to specify which are those 4 possible number of n paths. So that will be entered by an once again taking in consideration into a path. So that is the path what I am going to, if I write an pi is pi, that is when it will be when that is p is equal to 5 means again the I will be written with the value of n 5, but whatever thing the column remains the same. Next, once again once we have done with this, first I am going to take a first element. If the first element remains the same with the source and destination, so the path will doesn't going to be executed. The minimum path will be a minimum is 1, the whatever the cost is be done. So if not, suppose if I want to check, I need to check each and every. So this is line is used to check the each and every distance from a source to the destination. Once we find out all the path, that is all the cost of all the paths, then we going to find out which is the minimum path in a 4 possible paths. So to find the minimum path, I have got an equation with a condition called minimum is greater than or equal to t of I. So this minimum will give that which is the minimum cost, that is which is the minimum distance or a shortest distance, overall distance to reach the data from the source to the destination, and those paths has to be printed on the monitor. So we use one more condition which is called as an printf minimum cost matrix path is. So this is the working flow of the program. So now we are going to show that how it is executed. So once we have been typed the program, save the program and close the terminal, that is the G editor window. So open terminal. So open terminal and get navigated into the desktop. So once you get navigated into the desktop, So if you say SL, so CD space DES desktop, I'm navigating into a desktop. In a desktop I have found a file called vector.c. So compile this vector .c by using a GCC compiler which is available in an Ubuntu. That is GCC file name, that is a vector.c. So once it has got compiled, with that, next I need to run the execution, that is executable file. To run the executable file, I have gotten a keyword called dot slash a dot out. So this will runs the output of a particular compiled, what it has been compiled. So when you say enter, it will ask for the enter the cost matrix. So to enter the cost matrix, so first I will return a 5 cross 5 because the maximum value what I have taken a 5 cross 5. So if the maximum value is 10 cross 10, so you can give up to a 10 cross 10 matrix. So I will write those which are the possible matrix as shown in a previous session, that is an 0 1 4 2 0 0 0 0 2 3. The same thing will be clarified with the values, that is an first one 0, sorry, so run 0 1, next which is the next thing 4 2 4 2 0, and next column is 0 0 0 2 0, and next is 0 0 3 0 0 0 3 0 3 0, next 0 0 0 0 5, finally another is 0 0 0 0 0. So these are the cost of a matrix. Next enter the path is a 4. So enter the possible paths, that is how many number of possible paths that will be done. 1, next 1 4 5 0 0, 1 3 1 3 4 5 0, next. So this will calculate which what is the minimum cost that is required. So the minimum cost is in 4, and which are the possible paths, that is in 1 2 5 0 are the possible paths that are available to reach from a source to the destination. The same thing will show for a different network with taking a consideration of another. So we'll run the same thing, so within different. So I will give from a node 0 to node 0 as a cost is 0, from node 0 to node 1 as an 2, from node 0 to node 3 as an 5, node 0 to node 4 as an 4, node 0 to node 1 is as a 1, and similarly from node 0 to that is node 1 to node 1 is 0, node 0 is 0, next node 1 to node 1 is also 0, node 1 to node 3 is 2, node 1 to node 3 3 4, next 0 0 0 5 0, next 0 0 0 0 1, sorry 1, next 0 1 1 1 0. So this is the mark. So it will ask how many number of possible paths that are available. I will give it as a 3 possible number of path. So in that, which is the possible, that is number of path is 3. Enter the possible number of path is then 3. Once again I am going to enter that is which are those possible paths. Sorry, the minimum cost is 5. So the total which is the possible, that is 3 1 4 5 0. So thank you.